All right. Are you guys good if we start? Yeah, let's get going. Good morning. Thank you for joining us today in the Cisco U Theater. My name is Kareem Iskander. I lead technical advocacy here at Learning and Certifications. And today you're here because you want to learn about Git. So just show of hands, who's done something with Git here? Okay. Depth, like one. Okay, very little. Okay, so this is good. This is going to be a good intro. We're going to cover a bunch of topics, but mainly want to have you walk away with a good understanding of Git and how you can leverage it in your automation and programmability journey. We're going to talk about the merging and pulling, which is something that you need to actually understand as you start collaborating with your team, or you start collaborating in the community into pushing code. You need to understand how to properly merge and how to properly do a pull request. And then we're going to touch a little bit on a more advanced topic, interactive rebase, just because it's something that I think is really, really useful throughout that you should understand about Git. And typically, when you first get started with Git, you wouldn't have to touch on that, but I figured I'd give you a taste of it. And then we're going to talk about search and find and expand on our knowledge from there. Okay. If you have any questions, feel free to stop me and ask it. I'm happy to answer it as we go. Okay. So, what is version control? Version control is a system that manages changes to a set of files. If you think about this, if you come from a data center world, right? You go out and you create your VM, you put the libraries that you require on that VM, you install the OS, and then you take a snapshot of that VM so you can use it to as a cookie cutter for other things, right? That snapshot is the history of that VM. It's Git is very, or version control in general is very similar to that, where you write code, you have your working directory, you do what you need to do in that code. You have an Ansible script or a Python automation script that automates your Meraki deployment, and you finish that feature. You take a snapshot of it and you save it, and that allows Git to essentially know that, hey, I have a new version of my code. Okay, so it's a way to versionize your code. So, what is Git specifically? Git is an open source distributed version control system. It essentially stores snapshot of your code. So, think of Git as the protocol that allows you to take these snapshots, right? And so, one thing that you need to understand also about Git is um, every time you do a snapshot, you take a complete copy of every single file. So changes are stored in trees, and trees contain changed files, as well as each commit contains these trees. All right, so you hear this a lot out there, and I when we talk a lot with network engineers that are looking to get started with Git, we what I realize is there's a confusion in the market around GitHub and Git, and the terms are used interchangeably. So I want us to be clear on something. Git is the protocol itself. GitHub is the hosting site that allows you to save your code out to the public, right? So GitHub is just a flavor, right, of these websites. You can have an on-prem deployment with GitLab. You can use the GitLab um, cloud deployment for the same exact thing that GitHub does, right? It's just a hosting company, but everything underneath that, all the protocol, all the interactions that happen with your code, you use the Git protocol itself. Okay. So some terms that I think are useful to understand when you first get started with Git is that we're going to talk about here is for starting with repository or repo. Repo is essentially the folder or a vault of storing version control files. This is think of it as a folder on your file system or a folder in GitHub. It's called a repository or a repo. And a repo could contain code, it could contain documentation for an API, it could contain all sort of files within that repo. Working directory is the visible directory and its content. This is essentially your local working folder that you have all your code, and it also contains some Git configuration files that differentiates it from a normal folder and a Git working directory. Versioned files are files that you told Git, I want to versionize these and I want you to track them. And unversioned files are essentially files that you told Git that you don't want anything to do. I don't want you to track them. And you're going to ask me, well, isn't the whole purpose of Git is for us to track everything? Um, yes, it is. But I want you to think about this. And I want you, this is why there is a way to say, I want you to I don't want you to follow or to track these files. So we're writing an automation script, and part of your automation script, you need to make a connection to devices or to your data center. These config files reside within your code somewhere, right? Hopefully they're encrypted, but you don't want Git to track your configuration files, because then anytime, anywhere you share that Git repo, everybody has access to your credentials. So this is why it's important to tell Git that I don't want you to versionize this. I want you to ignore them. And I want you to only care about my configs, or sorry, my automation scripts in that, or my code itself. Also, things like settings and preference in your IDE could reside within your code itself, and you don't want to share that. It's unnecessary. So this is why it's useful to know that you can tell Git to ignore some files. Now, if a commit is essentially a way of telling Git that I'm ready to take a snapshot, and we'll see how we can do that via Git commands. But a commit is essentially just take a snapshot, and that basically creates an entire commit. It moves the header pointer to the latest, to a new commit, and you can do some magic there, and we'll see how we do that. Okay. And then branches. Branches are basically a logical separation of the code that you grab and your features that you work on. So think about this. You found a repository on GitHub that does about 90% of what you need for your automation. You decide that you maybe need to add a little bit more, a new feature to it, but you don't want to break that base code. So what you would essentially do is you would create a branch. That branch would contain a copy of what's in your main branch. You give it a name, and you can start coding in that feature branch. That feature branch would have its own commit history. It would have its own copies of whatever you've done in that branch, until such time you tell Git that, hey, I'm ready. I've finished that feature. I want to bring it into my main branch or merge it. You're safe. You haven't touched that main branch, right? And we're going to see, as part of the merge and pull request, we're going to see how we do that. So a branch is essentially a safe place for you to work. Does that make sense? Okay. So let's look at some of our basic Git commands that you'll need to learn. And these are basically, I would say you would live in this for about 75% of the time that you're using Git. So first of all, you gotta go set up Git. Git is a package that you can get it via command line, or you can use the GitHub GUI. They have a GUI application that you can install. But as soon as you first set it up, you have to config Git. So you have to tell it who you are by using the git config -- global user.name and user.email. And the reason why this is a one-time step that we must do is, think about this. Again, the whole purpose of Git is for us to be able to collaborate on a project together. And every time you do a store, or every time you do a commit, Git creates a snapshot. And when you create that snapshot, it saves it into the log of that, or the history of that repository. So we would like to be as a developer, we would like to be able to differentiate who pushed what when. And this is why it's important to supply your username and your email and your name, because if I do git log and I look at all the entire log of that repository, it's going to show me that Kareem Iskander with this email has submitted this feature with this message on day whatever, right? And so I could actually track who's done what changes to my repository. Now, remember the use case where we said you you want to go out there and look for some base code on GitHub. You want to be able to download it into your working directory, right? So git clone followed by the URL that would allow you to basically say, hey, Git, I want you to go from this site, get this code and download it. Git is going to download it. It's going to create a folder in your file system with that repository name, and then it's going to have the code that you need in there. It's going to create it in the main branch. Anytime you get Git from, you download a repo from GitHub or whatever hosting company, it's always going to be in the main branch, and then you can start your development, right? You can go create a new branch. You can choose to go crazy and work in the main branch. It doesn't. It's there for you. So that's a way to download. So git clone. Now, as we're building our application, as we're writing code, you make changes to your file system, your working directory, right? But maybe you're working late at night and you go to bed and you wake up in the morning and you don't know if you've committed or you've done, what have you done, what status is Git in. Git status is your friend. So Git status would tell you, okay, hey, I've noticed that you've created a new file or you've edited an existing file, but I'm not tracking those changes. I need you to tell me what to do. So Git is going to give you a hint, and we'll see that. It's going to say, Git, please go ahead and do a Git add so I can track them. And then if you do Git status at that point, it's going to tell you, you've added this file. I am tracking. However, you have not taken a snapshot yet. And therefore, you got to do a Git commit, right? And so it's going to give you a hint on where you are. So Git status is really your friend to keep track of where you are in the life cycle itself. So we talked about branches briefly. You want to be able to go out and create a new branch. How do you do that? So there are two ways. You can simply say git checkout a branch name, right? So git checkout feature, for instance, that would be my branch name. And then you go and say git branch feature. So git checkout, I apologize, the other way around. So git branch feature, that would create a new branch, but it's not going to move you to that branch. You're going to be sitting on main. Okay. Now, if you want to go and start building in the newly created feature branch, you have to go git checkout feature. That would essentially move the pointer from your main branch to your feature branch and then switch it over. Or you can make it simple for yourself and just remember the -b flag. So git checkout -b, that's going to create a new branch for us, as well as move the pointer over to the newly created feature branch. Question? Exactly. So the question is, git checkout branch name will point it to the existing branch. Yes, it assumes that there's a branch there. And if it doesn't, it's going to tell you no branch exists. Yeah. Now, tracking, again, git add is telling Git that I want to versionize the specific file. So git add followed by the file name, or you can use a wildcard, a period, instead of file name. It will add everything that you've made changes to in that working directory. Now, creating a commit, right? So git commit -m. This is saying I'm going to take a snapshot. I'm going to versionize my files. -m is a mandatory flag. So, and think about it logically from, again, if I'm looking at a log, right? I want to be able to see who has done what, but what features were pushed too. So as part of your message, you got to say, I've added to my automation script, I've added camera deployment support for Meraki, for instance. And that tells the developers that are going to use your library which features were pushed when. And it could also allow me to basically check out the same code from different commits, just in case I don't care for the commit. I don't care for the camera commits. I can just go back and basically use the code from there. Does that make sense? And then if you want to create, excuse me, if you want to create a branch from a specific file, then you can simply say git checkout file name, and that's going to basically create a branch with that one file. So you can start maybe building a feature according to that file itself. So you don't need everything in the main branch. So let's look at a basic workflow for Git. And this is, you're going to find yourself, once you start adopting this is where you're going to be living. Okay. So first of all, you're going to go to a hosting site somewhere. I'm going to assume GitHub here. You found the code that you like. What are you going to do in order to get it on your workstation? What's the command? Git clone followed by the URL. Exactly. So I've I've cloned it at this point, and it came as main. And now I choose to do what I have a couple of decisions. I can work in main, or I can create a branch. In this case, I've created a branch called my code. So what is the command to create a branch with my code? Git checkout -b followed by my code. So I've done here now. Git has moved me over to the my feature branch, my code, and then I start coding. So at this point, if I do git status, so I wrote some files, I edited my Python script, whatever it is that I've done, I do a git status. At this point, I get a red that says, hey, I'm not tracking your changes. You got to do what in order for me to track the changes? Git add followed by the file name or a period to add everything. Now, I go here and I've told Git that I'm tracking the changes, but I haven't created a snapshot. So I'm going to do a what? Git commit -m followed by a message, and I'm green. Everything is good. Now, I live in this triangle for the probably 75% of the life cycle of my code, because I go make changes, I track them, I commit. Go make changes, track them, commit, right? Until such time that I'm done with all my feature that I've built, I can go back out and merge into main, right? And we're going to see what that is. And then after I merge into main, which means all of the features and all the code that I've made in my feature branch now becomes part of the main code in the main branch. And then you got to go do a push and a pull request in GitHub to tell the integration manager that, hey, I've created a new feature, or maybe I fixed a bug. Can you please integrate it on GitHub? So the next person that goes out to GitHub can get the latest code with the latest feature. Okay, so that's kind of essentially the life cycle that you see and you would do in Git. What would happen if you don't add? It will tell you there's no new changes because it hasn't tracked it. So that's a really good question. The question is, what would happen if I just go do a commit straight? So I made some changes and I do git commit. Git is going to tell you I don't see any changes because nothing has changed since last commit because you didn't add it. So it's a good question. Say that again, sorry. You here, this is all on your local. So the question is, how do you collaborate? All of this is happening on your PC, on your personal computer, right? There's no collaboration here yet. The collaboration happens when you do a merge and a push to GitHub or to whatever hosting company, right? So what's going to end up happening, all of your commits, all of the changes that you've created in that feature branch is going to actually get appended to the history of the main branch. So now all of the commits are going to show up on top of the list, and your new code is going to be here until such time that you push it out to GitHub. There's no collaboration yet. Okay. Then it's fine because you're working on a feature branch on your own, and he or she have their own branch working locally. When you go and push it out to GitHub, there's going to be two new feature branch created there. The integration manager itself, the owner of that repo, is going to say, okay, branch one has this feature, branch two has this feature. I'm going to merge them on GitHub, and there might be creation of merge conflicts, right? And the way that that works is Git checks every single line of code against the merge that the file that you're merging. So if line one has import JSON, for instance, and line one in the branch has import requests, these are a mismatch. So Git is going to be like, I don't know what to do here. You, as the integration manager, you have to go and resolve that merge conflict. And this is how it protects you from overriding each other. Good question. Okay. So this is a great segue for us to talk about merge and pull requests. So merging is designed to integrate changes from one branch into another. So let's look at this use case. Your multi-site Python deployment, automation of the main branch for your Meraki deployment. The main branch also contains newly added Meraki deployment, and then you're building a feature branch. You're building a feature branch on the Meraki that includes some camera deployment for the site. How do you merge? So you've already built the feature. You're all ready to go. There are two ways. Excuse me, I'm losing my voice. There are two ways to do so. One is git checkout feature, which means you got to be on the branch that you want to merge from. So you got to get there. And then you tell it while you're sitting on that branch to git merge into main or whatever feature branch that you want to merge into. So you got to be on the branch that you're gonna merge from, and then while you're there, I'm gonna merge into this, and it's a two-stepper right here: git checkout feature, and then git merge into main, and that would copy all of the commits, all of the files over. Now you can be anywhere in Git, in whether you're on main or on the feature branch, and simply use git merge feature into main. So that's going to basically take whatever's in feature, merge it into main. You don't have to actually go move your pointer to that branch. Okay, so two ways of doing it, whichever you're comfortable with. So something to just keep in mind, merging is a non-destructive operation, which means goes back to my comment about merge conflicts, right? If you run into merge conflicts, it's going to throw an error. So it's never going to overwrite. And then existing branches are not changed in any ways, which means because because I merge feature into main, it doesn't mean feature gets dropped, right? It's still there. You could choose to clean it up, right? If you're the integration manager, to after you made sure the features got copied over to main, you can drop or delete that branch, but it doesn't hurt to just keep it there. And another thing that you got to be conscious of is as you go and commit in your feature branch, all and every single commit that happens in your feature branch gets copied over into main, right? And so if you're committing every single line of code and writing a message, and your main is going to be shared with in like a production code or something, if anybody goes in and sees a log of that Git repo, they're going to see hundreds and hundreds of commit messages. So be conscious of that when you're doing commits. And typically, the integration manager or the owner of that repo kind of defines the rules when you're working in a DevOps environment. They say, okay, we're going to build a repo. These are the rules of that repo. You never work on the main branch. You work on a feature branch. Do a commit at least once at the end of the day, or maybe every after. There isn't really a specific rule on the number of commits, but it's kind of like an unspoken rule. Typically, you write a bunch of functions and you do a commit to be safe. That's how it works. Okay. Yes. If the question is if you branch out of main, yeah, but the changes that, so the question is if you checked out an existing branch, if you've made any changes to that existing branch, it becomes it becomes not synchronized with the main branch anymore because you've made changes. There are new commits, there are new files, whatever it is. So if you need that feature to be part of main, you have to merge it. It could stay there, and you can instruct your developer to say, if you want a camera deployment, it's not in my main branch, but you can switch over to the feature branch and you'll see the camera deployment. Maybe this is not a high priority feature that you need to have. So you don't need to merge it then, but it's always going to be a mismatch at anytime you make a change to a feature branch. Okay. Do you have a question or? Okay. All right. So keeping in mind that everything that we've done here is local, the question was, how do you integrate it, right? Just because I'm working on my local system, it doesn't mean I'm collaborating yet. And just because I've merged it into main on my local system, again, it doesn't mean that it's on the main repo, where I've downloaded, I've cloned that repository. So this is where pull request comes in play. So basically, in the real world, you're never going to be the owner of that repository, right? Chances are there's going to be an integration manager. They're going to create that repo. You're going to only have a collaborative rights to it, which means you can clone. But then there is a way for you to integrate your code back into main, and this is via pull request. Pull request is essentially telling the integration manager that, hey, I have a new feature, whether it's a branch or not, right? I have a new feature. I am making a pull request so you can pull it into the main repository on GitHub. And that pull request is essentially happens this way. So first of all, you got to actually push it up to the GitHub. So you do git push. Origin is the main repo in GitHub, right? So it's it comes down as main. When we push it out, it's called origin, right? And then you specify your feature branch or whatever the branch that you want to push out. So git push origin to feature, that tells Git that whatever is in my feature branch, I'm going to push it out. You log into your GitHub account or GitLab account, whatever it is. You're going to see a message that says, hey, I've realized that there's a new feature branch that needs to be pushed here, right? So they're going to give you an option to say compare and create a pull request. And then so you click that, you leave a note to the integration manager saying, I've built so-and-so in this feature branch, and it does whatever. As an integration manager, after I say submit, I'm going to get a notification that says, hey, Kareem has submitted this. Can you please go look at it? And so I can look at it. I can see the diff in files. It tells me what has changed. I can see all of the commits. And based on that, I have two actions. I can accept it and say, okay, this is now part of my main repo, and it gets merged on GitHub. Or I can reject it, and you get a message back that says it was rejected for X, Y, and Z. And this is how you collaborate. So now we see the entire life cycle of this. Okay, so I was going to go into interactive rebase, but I don't have a minute to cover this. So, but what I'll tell you is interactive rebase is with all of the commits that we do, it's basically the Swiss Army knife of Git, and it allows you to essentially edit your commits. So we talk about taking snapshots, creating messages. Maybe one of the things that you've done is you've built the feature branch with hundreds of commits, and you realize you don't need half of these commits. You don't want to delete your feature branch, right? You can go use interactive rebase to basically say, I'm going to delete this commit, or I'm going to merge a couple of commits together, or maybe I'm going to change my my message because there are some typos in that commit. So interactive rebase allows you to do so. And the way that this happens is you essentially go and decide, okay, so every commit has an entry in the Git head, right? So the head pointers start from 1, which is our latest commit, and to N, which is the very first commit of that repository. And so you gotta tell Git how far back you want your pointer to go in order to edit those. So in this case, I want to edit head 2. So I could give it a range. So I could do a git rebase dash interactive head 2. That's gonna give me access to this. I could also have gone head 3 because it includes 2 and just access 2, right? And then determine the action. I can do reword. I can do reword would allow me to edit my commit message. I could do um, join. I could do split. So basically, all of these are actions that happen on your commit messages itself. And then to see the changes that happen, I simply say git log one line, and it will show me all the commits and that change. So I know it's a lot. This is a more advanced concept. I'm happy to discuss it further with you. I did a session yesterday in the DevNet Theater that covers all of this deeper. So if you go on Cisco Live 360 and look for advanced Git in DevNet, watch that video. The slides are there as well. And it gives you a little bit more deeper view into some of the tools. So with that, thank you guys so much for your time. We got to do the raffle, and I got to rush over for another session back there. All right, and the winner is 346620. 346620. No one? Going once. 620? Huh. 346589. Yes, we got a winner. Thank you guys. Thank you for your time.